All right, hey, good afternoon, everybody. Thanks for bearing with us there for a few minutes extra. We're excited that you're here joining us this afternoon. My name is Greg Jones. I'm the editor of Engine Builder, and today we're very excited to be bringing you this live stream focused on best practices for cleaning engines and parts. And I'm here today with two cleaning experts from Armex in Brian Waple and Andy Logan. Brian is the business manager of performance products at Armex and is as knowledgeable about cleaning products and methods as anyone in the industry. That is, however, with the exception of our second expert, Andy Logan. Andy is a senior chemist at the ArmorClean company and has nearly 30 years of experience working with soda blasting and nearly 25 years of experience with Aqueous Cleaning. Andy's been instrumental in both the company's template for modern soda blasting and in safety-kleen's adoption of Aqueous Cleaners in their product line. During today's event, we'll be talking with Andy and Brian about improving your current cleaning process while saving time and resources. Guys, welcome and thanks for being here.
Hello. Thank you.
Now, before we get started, I just wanted to go over a couple of housekeeping items for the audience. Again, glad you guys are here. We're excited for today's event, and we want today's event to be interactive. We have Ask Andy here today for a reason. So if you have questions for Andy, please feel free to type them as they occur to you. And there's a couple different scenarios here for you in terms of doing that. Now, if you're using a computer or tablet, there'll be a GoToWebinar frame on the right of your screen, and near the bottom, there's a questions tab. If you click that triangle, it'll open up the box so you can type your question there and submit it. If you're on a mobile device, you'll probably have like a header or footer or picture frame around your screen, and you should see a question mark, which is what will allow you to type your question. And again, feel free to type those at any point, and we'll get to those at an appropriate time. There'll also be a Q&A section of this event as well. And if for any reason someone loses their connection during the event, you can re-enter using the same link that you used to join currently. So again, thanks for everyone for being here. And without further ado, I'm going to turn it over to Andy, and we'll kick this thing off. So, Andy, it's all yours.
Hello. Thank you very much, everyone. I'm glad you could join us. I'm talking to you from our ArmorClean Technical Center in Rocky Hill, New Jersey. You see a lovely picture of actually in Rocky Hill over by the Delaware and Raritan Canal. And so let's get started. Who am I? Well, as I was introduced, I'm Andy Logan. I'm a senior chemist with Church & Dwight Company, and I've been doing technical support for the ArmorClean company since its inception back in 2000, and even before that, when we were forming the joint venture. I've been doing soda blasting for close to 27 years, somewhere around there now, and I've been doing aqueous industrial cleaning for about 24 years. One of the things that we've been involved with, even before the term was coined, was the circular economy, where you make your components, and somewhere along the line, you need to clean them when you're making them for the first time. But when those components become old and no longer useful, they get repaired, they get remanufactured, either to make parts or to make machines. And we learned that there are cleaning opportunities that are required for those parts to be turned into new parts, new machines, or back into the raw materials. And so there's a lot of different types of cleaning methodologies that come along with that. And what I'm going to start off with here today, before we really maybe get into discussing some of the applications that are of interest to you, particularly, is the technical aspects of the various broad cleaning methodologies that we're using: organic solvents, using aqueous cleaners, and using abrasive cleaning methods, and why they work the way they do and why we go about choosing those. So I'm going to start with organic solvent cleaning. One of the key things to understand is that we used organic solvents for a very long time because they work very well. they clean hydrocarbon soils, which for engine remanufacturing is one of the key soils to get that need to be removed, either from the original manufacturer, you're talking about your metalworking coolants, or the various oils and lubricants and just materials that get onto the engine over the course of its service life before it goes into a remanufacturing cycle. Key point about organic solvents is that 100% of those molecules that are in that solvent that you're using to clean are the cleaning molecules themselves. Solvents evaporate, which makes it easy for when you're doing the cleaning for your cleaner to go away. And because the solvents evaporate, the only thing that gets left behind, and this is a technical thing for someone like myself, is whatever tiny molecules of soil are left in that particular solvent drop. So why do they clean so well? Well, I want to talk about the chemistry of organic solvents. This is a stick figure for an organic solvent molecule. And the key point here is that your hydrocarbon soils, your greases, your oils, your all that crud that gets onto your engine when you go to remanufacture or it needs to be repaired, their chemical structure is, for the most part, very similar to the organic solvents that are used. Basic principle, like dissolves like. So that organic solvent cleans so very well because its molecular structure is very similar to the grease and oil molecules you're trying to remove. So you have a surface, you've got dirt on that surface, you put it in your solvent bath, and the soil comes off, and just about everything evaporates, except for maybe, like I had mentioned, those couple of dirt molecules that were left behind in that drop of solvent when you pulled it out of your solvent bath. What are the downsides of organic solvents? Well, when you talk about it technically, they work very well. But we have learned over the past decades that there are hazards. Some of them were always known, but were accepted. And now, as we move into our current times with regulations and social mindfulness and risk management, and that's a key thing, risk management, those hazards are a concern, and they add to the cost, not just the dollars and cents of purchasing the solvent, but the cost of using that solvent. Fire hazards, health hazards, environmental hazards. So when you start looking at an application, it isn't just the technical aspect of doing the cleaning that makes up why you want to choose what you choose to do your cleaning. These hazards may be deemed unacceptable from a risk management standpoint. And when you start talking about risk management, one of the key points is that when your environmental health and safety officer is going to say, well, can we get rid of it? Well, we need to do this process. Well, can we supplement it? No, not really. Well, what are the engineering things I need to build around my process so that I can handle it safely for my workers, for my work environment, and for the efficiency? And then the cradle to grave, I have to dispose of it. Aqueous Cleaners came into the picture for this type of cleaning as a result of some of the downsides I had mentioned about organic solvents. But aqueous cleaners are more complicated. I've shown you the various components here that are needed. You need the soap itself, the surfactants. You need alkaline builders to create the appropriate environment for cleaning your soils off. You have your water itself, and you have defoaming agents because it's soapy water. If you have agitation and you aerate that product, you're going to have foam, and you're going to need to control that. Most people don't want to have this cleaner come out of the bath and onto the floor. And then you have corrosion inhibitors formulated into your aqueous cleaners. Why do we do that? Well, water is a hostile environment to your metal components. Water facilitates all types of corrosion functions. And so these corrosion inhibitors impede that corrosion formation while the parts are being cleaned in essentially a hostile environment. So with aqueous cleaning, why does it work? Well, we've talked about the organic solvent molecule, and we've talked about how it's similar to the grease and oil molecule. Water is nothing like that. Water has a different molecular structure, and it's a lot smaller, relatively speaking, than the grease and oil molecules that we're talking about. And grease and oil doesn't want to have anything to do with water. So we rely upon the surfactant molecule, the soap molecule. And a soap molecule has its own particular chemistry, which allows it to work. One side of a soap molecule has a water-loving head, and the other side has an oil-loving tail. So what you're looking at is the water will hang around the water-loving head, and all that grease and oil and dirt molecules you're trying to get off are going to hang around with the oil-loving tail. And all of your soaps work this way, from your dish detergent, your hand soap, your laundry detergent, and yes, our ArmaClean industrial cleaners are all using molecules that work just like this, though they'll have different properties depending upon what the soaps are chosen to target cleaning for. So you're cleaning. You have a dirty surface and you put it in your aqueous bath. And in that aqueous bath, you have your soap molecules. You have your builder molecules to make the appropriate environment. You have your corrosion inhibitors to protect that metal surface from the water environment. And you have your defoaming agents to control foam. Dirt will come off that surface, hang out with the soap molecules. Now, here's a key point. Aqueous cleaners are formulated most of the time to meet regulatory requirements for volatile organic carbon content. And as a result, the only thing that's truly volatile in an aqueous cleaner is the water itself. You can see here graphically, everything else gets left behind, your soap molecules, your builders, your corrosion inhibitors. So we know that we leave a film behind. And this isn't just with the cleaners that we make in ArmaClean. This is typical for aqueous cleaning in general. And so we have always recommended a freshwater rinse, which becomes part of the application logistics consideration. If you're using aqueous, you will need to rinse unless for some reason you've determined those residues do not interfere with whatever is the next step in your remanufacturing or manufacturing process. Downsides of aqueous cleaning. Well, one of them is actually the water itself. Water and greases and oils and other hydrocarbon soils generally don't mix very well. If they did, people would be out back with a garden hose and we wouldn't be having this webinar or conversations much like it. So the water is a downside. Remember I was mentioning the organic solvents, 100% of those molecules in that bath are the cleaning molecules themselves. When you're talking about an aqueous cleaner, only a small minority of those molecules, the soap molecules themselves, those surfactants, are the cleaning molecules. The rest is carrier, something that will help hold that soil away from the surface, but in general isn't doing the actual cleaning itself. So the concentration of your cleaner is important. And a lot of times, even going to 100% cleaner concentration isn't going to help you because you do need the water because that's how the surfactants work themselves. Remember, they have a water-loving head. Aqueous cleaning in general takes longer than organic solvents because you don't have 100% of your molecules trying to grab onto the dirt and pulling it off the surface. We, in general, heat our aqueous cleaners to make up for that reason. So in general, your aqueous cleaning is going to be done with a heater, which does mean that part of the downside is you have to allow for heating that bath up. And there is a limit to how hot a cleaner can be if you're doing a manual parts cleaning methodology. To keep people from being burned, you generally top at 120 degrees Fahrenheit. For automation, you can go higher than that. Generally 160, 180 degrees Fahrenheit are not uncommon for an aqueous bath to be heated to. Abrasive cleaning. It's just as it sounds. You're going to take particulate and you're going to use that particulate that you project at a surface and scrape off the soil that you're looking to remove from the surface. And you are going to have different hardnesses of the media that you're talking about. And they're going to range in hardness to things that we generally categorize as hard, like steel shot and aluminum oxide and the original sand. And then you have your softer medias, which baking soda is included, along with dry ice and calcium carbonate and plastic medias. Though plastic media is interesting, it has a range of hardness depending upon the type of plastic it is. And when you go to do abrasive cleaning, the hardness of your media isn't your only consideration. It is equally important to understand the hardness of your coating, because they range in hardness from something as easy to remove as greases and oils to failed paint and burnt on carbon or cooked on hydrocarbons, all the way up to scale and rust and forging slag. Those things get very hard and are metallic in hardness characteristic themselves. On the substrate side, you need to understand when you're selecting an abrasive media how hard your surface is, because that will determine how hard your abrasive can be. Because what you don't want to do is have unacceptable damage to your substrate. And it's important, unacceptable. If you are purposely trying to remove substrate material, well, then that is not a problem for you. It's acceptable. But if you're trying to preserve your substrate, the hardness of your media could cause unwanted damage. When you're doing abrasive blasting, why does that happen? Well, it is that relationship I was just talking about between the hardness of the particulate itself and the substrate. So let's start with a particle. You're going to shoot that particle at a surface. Now, if that particle is harder than the substrate surface you're attempting to clean, the energy of that impact is going to be transferred into the surface and fracture and break that surface, abrading it off. It does that to the soil too, but in this case, you need to be mindful. If this is not what you want to be doing, this is what is going to occur. With your softer medias, Armex soda blasting media being one of the softest, and yes, baking soda is a crystal shape like that. In this case, the surface is significantly harder than the crystal, and when the crystal hits the surface, that energy of impact is shattering the crystal and your substrate is preserved. So and these relationships are just that, relationships. It's always a matter of the relativity of the hardness of the surface versus the hardness of the media and the hardness of the coating that you're removing. Usually, your coating is less hard than the surface. In certain instances, if you're abrasive cleaning off composites or wood, and I know that's not a big thing for engines, but as an example, wood is very close to hardness to even baking soda. In those instances, you could have crystal breakage plus have the surface abraded as well. And that can even happen with your harder medias like glass. If you're blasting at too high a pressure, thus imparting too much energy into a glass particle, and it hits a steel surface, you will fracture that glass and reduce the efficacy as you recycle that glass for recycling use. And you end up with your various surfaces that you've abrasively cleaned, and you have all those considerations. As you can see here, these are parts that we did with soda blasting, because these are the pictures that we have readily available. That's what we do. And you can see some before and afters. Now, if you have an application with heavy corrosion, a soft media like sodium bicarbonate, baking soda, is not going to remove that corrosion because the corrosion is in the substrate and you need to do substrate removal. So that's a key point. If you're looking to get to a white metal finish on parts that have significant corrosion on them, a soft media is probably not going to be a good choice for you, and you'll be looking at hard media. But if you have the added concern of hard particulate being caught within the channels of your mechanical interfaces, and that would cause damage to your part, and you're very concerned about that, baking soda being water soluble, a characteristic of that media, makes it useful for cleaning off the hydrocarbon soils and the burnt on carbon, being able to rinse it out, knowing that you dissolved all the crystals, and leaving a part that is free and clear of particulate and ready for reassembly. What are some of the other downsides of abrasive cleaning? It is very difficult to automate abrasive cleaning because it's line of sight. Consider a flashlight. Your photons of light come out of the end of the flashlight and it strikes a surface, and you can see where the light hits because you can see where the shadows are. Those are areas that light doesn't directly hit. Same thing can be applied to abrasive blasting. You are sending particulate out of the nozzle, and if there are areas that the particulate can't strike, essentially making a shadow, those areas are not going to get cleaned. And so if you have a part that needs to be rotated and has interesting geometries, it may be difficult to set up some sort of automated mechanism to hit all those areas, especially if certain areas will require more dwell time, meaning your nozzle needs to hang over top of that particular area before you move on to cleaning another dirtied area. Here are some examples of the types of tools that you would be using for abrasive cleaning. Abrasive cabinets. Now, these are primarily soda cabinets. I understand that, but your glass bead and plastic media cabinets are going to look very similar, especially for engine rebuilding applications. You absolutely can size this type of containment concept to hold tanks and cars and planes, but for engine components, you're probably going to be at the more human size, as you see depicted here. And these are examples of aqueous parts washers. Organic solvent parts washers will have similarities, especially for your manual sink on the drum that you see in the upper right-hand corner. You have immersion tanks, which essentially, just as they sound, they're tanks that hold the cleaner, and they can be agitated, be non-agitated, agitated, or they could be what we call spray under immersion, which is we create a jacuzzi-like turbulation inside the machine to get a lot more roiling of the cleaner and more effectiveness of the cleaning. And then you have ultrasonics, which are very energetic, and spray washers, which are essentially dishwashers for your industrial parts. And aqueous cleaners can go into all of these, and even depending upon the organic solvents, you can use some of these same techniques. I don't have one pictured here, but organic solvents also utilize a type of technique called vapor decreasing that some of you may be familiar with. For those of you who are not, that is where you take your solvent and it's in a sump that is heated. It causes the organic solvent to be vaporized. The part is suspended above the liquid layer and allows the organic vapors to condense on it and allow that organic solvent to then drip back down into the bath and thus cleaning the parts. As I mentioned, scaling. This is another important part of your consideration when you're looking at choosing a way to clean your various engine parts. How big a machine do I need? What is the complexity of my logistics? Can I get away with a more batch size operation, such as some of the smaller machines I showed you previously? Or do I need something much more complicated or involved because of the nature of the process and I have a lot of parts to clean in one place? Which brings us probably to the biggest question that you are looking to have answered today, was what's the best way to clean my parts? And from my technical standpoint, and it may be an unsatisfying answer, it depends. It depends greatly because when you start talking about applications, one application's perfect setup is another application's problem, not a really good solution for them. Examples like I had mentioned previously, corrosion removal. If corrosion removal is one of your primary concerns and you need to do that quickly, you're going to be looking at a very aggressive chemical, such as a very strong acid type rust remover for the purpose of rust, or something equally aggressive to remove aluminum corrosion, or you'll be doing abrasive cleaning with the purpose of doing some sort of substrate removal so that you get that surface clean. And then you go into the wider things. If you ask me what's the best material to clean off an organic soil, an organic solvent is, but then we go back to some of the downsides that I'd mentioned. For your process, are you looking at as a primary a secondary objective, make sure that your workers are safe, that you don't have issues with disposal of that organic solvent, that your EH&S is looking for a reduction in that risk because they don't want to have that risk present for the workers in place and for the environment and for the company's operations. A organic solvent that could explode or cause a fire is a potential risk to the overall business functioning. So it brings us to more of the open-ended portion of our webinar where I am available to answer some more specific questions. I felt it very important to go over the why does organic solvents works and why do the aqueous works and why do they not work sometimes, by giving you some very basic top line chemistry understanding of these and chemical physical understanding of the abrasive cleaning.
Andy,
Yeah.
can you talk a little bit about why baking soda is so good for removing grease and oil? That's probably one of the biggest contaminants removed toward engine building and remanufacturing engines.
Yes. Baking soda has a very interesting chemical property, which for abrasive blasting isn't it what we're using it primarily for, to get the grease and oil off the surface from a primary cleaning standpoint. It's the baking soda scraping it off the surface. But baking soda is, from a chemist's standpoint, an alkaline salt. Oh, excuse me about that. An alkaline salt, which means that if you dissolve baking soda in water, you're going to actually have an alkaline pH. It's not a strong alkaline. It's got a pH of 8.25. But that pH, in that pH range, greases and oils like to be with baking soda. And so dry baking soda particulate will actually absorb greases and oils onto its surface. So as it gets blasted off, that grease and oil molecules actually stick to the baking soda crystals, even though they're being shattered by the cleaning process, which actually in this case helps because we're creating more surface area. So that you can take a greasy, oily, drippy surface, and blast it with baking soda. And when you're done, without even the addition of water, you will have a grease-free surface. And that's a chemical property that you can take advantage of with baking soda blasting. It's one of the upsides because a lot of processes that use abrasive cleaning, if you were to say using glass beads or aluminum oxide or a similar grit to a similar insoluble grit, you would end up with getting probably bulk grease off, but you would end up with grease still on that surface because the grease doesn't want to transfer onto the particulate surface. In addition, a lot of the harder media, as part of the economics of their use, is the fact that they're going to be recycled. They're going to be blasted, recollected, and then put back into the pressure vessel for reuse. Generally speaking. And if you get any type of fluid, whether it be water or grease or oil, onto those particulates, it will cause them to stick to one another, interfering with their flowability, which means they will not be suitable for shooting out the nozzle again. So when you're talking about glass beading or plastic beading a surface, that part has to be cleaned of hydrocarbons before you do the abrasive blasting portion of the cleaning process. With sodium bicarbonate blasting, that is not a necessary step. Baking soda, as I mentioned, fractures. It is by design, as it were, or by characteristic, a one-use media. There is no pressure that you're going to blast that will preserve the baking soda crystal. Even at 25 psi, you're going to have crystal fracturing. So it's really only usable once out the end of the nozzle. So it could be a viable option for that type of cleaning application.
Very good. I just want to remind the audience to ask questions in the chat. It does not have to be directly related to Armex or soda blasting. These guys are experts in a number of cleaning methods. So please, if you have specific examples of things that you want to, ask these guys about, let us know. Andy, one thing I was curious about. Obviously, you mentioned application.
Yes, sir.
For what you choose as your cleaning method, but is it more a factor of the specific part that you're cleaning, or is it a factor of the soil that you're trying to clean off that part, or is it a combination?
It's always a combination. You always are in the process of considering. Now, sometimes you'll identify what is the harder part of your consideration. If you have parts which are, let's give an example. You have parts that are nice and flat, not a lot of nooks and crannies. You could very well use a spray washer, which gives you a fair amount of mechanical energy because you've got the sprayers at like 40 to 60 psi, depending upon the make and manufacturer of that spray washer. And that can definitely help get that grease and oil and those other hydrocarbon soils off the surface. But if you've got lots of nooks and crannies, channels, passages in that engine component, a spray washer is not going to get inside. And so you're going to clean the outside probably quite well, but the internal channels might be essentially untouched by cleaner. In those applications, the soil is readily cleanable by this cleaner you've chosen, but the technique isn't working for that geometry of the part. A better methodology for cleaning those types of parts would be spray under immersion or agitation immersion. I have a preference for spray under immersion when at all possible. There's more mechanical energy as the bath is roiling. Like I said, it's legitimate to call it a jacuzzi for industrial parts. The bath roils in quite the same way that your jacuzzi roils, and you have that liquid flow moving around, and that liquid flow will fill the channels. You'll have this turbulation. Some of that turbulation will cause flow within your channels, and that will help to draw the soil out and also allow more contact with the cleaner with the dirtied surface, cleaning more of the dirt off. So there's a very good example of where it's not just the soil, it's not just the part, it's a combination of the two that helps to dictate what types of techniques are going to be best for your application.
Excellent.
I guess one of the key takeaways too is a lot of times you're evaluating your process and what you're doing versus maybe improving your process is you have to understand, is what you're cleaning sometimes is the value worth the method you're going to be using, meaning
Yes.
that, some ways of cleaning cost less than others. Where if the part doesn't have a certain value, then it might not warrant, to soda blast the part or use a particular type of aqueous type solution or equipment. So there's a lot of classifying, not only what you're cleaning and how you're currently cleaning it. But the big question is, what's the value of what you're cleaning? And give you kind of an example, we've had some rebuilders of turbochargers that contacted us a few years back where they were having issues with how they were cleaning the products. They were solvent cleaning them, and then they were then doing a hard media blast to them. And they're finding out that the hard media blasting was damaging the threads. It was also, causing more rejected cores and things along those lines. So they were able to take their three-step process, they're cleaning, they're blasting, and then rinsing again, and convert it over to our MEX process, where we were able to remove all the grease and the oils and the burnt down carbons, all while not damaging the part. And, what they figured out in the long run was that, their prior process might have been a little bit more cost effective from resources and possibly, the cost of the materials to clean. However, the amount of rejections they were getting from damaged parts outweighed the savings on that end. So when they converted over to Armex, or I should say baking soda as well, they did not have those issues. So again, you have to kind of understand what you're doing, what you're trying to achieve. And Andy and I are very open about that, aqueous and soda blasting is not always the best solution. You have to find out what's the best solution for you. One of Andy's primary jobs is he manages the ArmorClean Technical Center. And through the ArmorClean Technical Center, you guys have the ability to send in parts. No matter what kind of part it is, and Andy can take that part and put it through Aqueous Cleaners, all those different machines he was talking about. We can also soda blast the parts. So that way, not only can you understand, what the process would be and how it might be able to improve what you're currently doing, but more importantly, you'll be sent back, the final result. You can compare that part to your in-house process and understand if the end product is better, worse, the same. And then Andy also puts together in his team a really great report, before and after pictures, how much time it took, what was used. So, that's one way of really, evaluating your current process and understand, is there a way to improve it? You can send parts in by going to either the armorclean.com or Armex website. You'll see a little box on both the home pages about get your parts cleaned for free. You click on that. There's a form you fill out. It gives you all the information, how to send your parts in. And typically how we work it is, you obviously pay to ship your part in, and we'll pay to ship it back to you. So there's no cost for you besides just physically shipping that part in. So that's a great resource to really understand, if what you're currently doing is the best way, and is there other ways out there to improve your process. I mean, that's one thing nowadays that we always talk a lot with customers. It's all about process improvement. You have to understand, is there a way to save time, save money, save resources, and then at the end, that makes your shop more efficient and obviously makes more money for you folks. And one word of caution is that, I actually had a customer in the transmission world that was remanning transmissions. They tried soda blasting, probably about 15, 18 years ago. And we had a discussion with them about 2-3 years ago at the ATRA show. And they were really turned off by soda blasting, mainly due to they physically couldn't see what they were cleaning. There was just so much dust inside the cabinet. Well, I can tell you now that there's a vast improvement in equipment out there. We don't make equipment anymore. We did back when Armex first started 30 years ago. We abandoned that, over 25 years ago. But however, equipment has vastly improved. So if you tried soda blasting in the past, you weren't very keen on it because, as Andy talked in his presentation, it's all about line of sight. If you can't see what you're cleaning, then how are you going to clean it? A lot of these cabinets out there nowadays, they have great extraction. There's minimal dust in them, but there's also give and take as well, where you have to kind of qualify what you're doing, your frequency of blasting, meaning that, as Andy says, there's Chevettes and Corvettes out there when it comes to blast equipment. If you're only going to be blasting, a few hours a day, a couple days a week, then you obviously aren't going to invest tens of thousands of dollars in a very complicated machine. If you have a very active shop where you have technicians blasting parts, 8-hour shifts all day long, then yes, you're going to invest in a more robust cabinet. So there is a little bit to say for, you pay for what you get for to a certain extent, but I think it's fair to say that all the technology out there has come leaps and bounds over the past, 5 to 10 years. And I think that if you had a bit of a shaky experience with soda blasting in the past, you might be pleasantly surprised on how much the technology has improved on the equipment side, which obviously would make your jobs a lot easier.
To follow up with what Brian was saying, as you look at your techniques, if you're looking at making changes or improvements, one of the things that we have found over the years that we've been operating the technical center is that customers sometimes fall into a commodity mindset. They look at the cost of just the one piece that they're looking at swapping out, organics, aqueous cleaner and organic solvent, that sort of thing. And or simply, well, I got a guy with us, doing his cleaning this way right now. A specific example, sink on the drum. He's doing it manually, and I want to get some sort of automation. But oh my God, you're telling me that it's going to, it takes you 3 hours to clean the part in automation. One of the things to look at, and this is where I was talking about looking at the entire process that you have in front of you, that while you may have an operator manually cleaning a part once every 15 minutes, and it might take me 3 hours to get that one part clean. Because I'm automating it, I can clean more than one part, and I may equal or exceed that operator's throughput. And if I equal or exceed that operator's throughput, you're also going to be able to capture that person's 3 hours. Instead of them standing at the sink, spending 3 hours scrubbing, they may be doing other things for your process that they weren't being able to do before. And so may very well see process efficiencies. We've seen that over and over again, that when we start talking with customers about their cleaning processes, they're interested in aqueous or interested in Armex, to make sure that they're considering their process and they're not trying to do a apples to orange comparison, if you'll allow me to use that analogy. Because sometimes when you're changing your process, by the nature of changing it, you're no longer doing some of the same things you're currently doing now, and you need to look at the entire throughput and the entire input and make sure that that's where you're picking up your improvement. I understand that some of your questions may be very specific, and you may have concerns. Again, I think I'm reiterating this, concerns about making them known here in an open forum. If you do have questions that you'd like to ask me but are uncomfortable with asking them in this type of forum, you can go to either armaclean.com or armex.com. And if Greg, you could just put that up in the chat for everyone so they can easily grab it. Either one, armaclean.com or armex.com. In there we have various inputs that essentially will end up getting those questions to me. Matter of fact, on ArmaClean, we even have one that is specifically just says, ask Andy, so it makes it even easier to find. So again, if you do have questions, I encourage you, if it is something you're uncomfortable with asking in this type of forum because you feel there's a level of proprietariness, we understand that. By all means, you can contact us afterwards at your leisure, and I will be more than happy to answer those questions. It's part of what I do for the Tech Center.
Yeah, absolutely. And Andy and Brian, we do have a couple questions here from the audience, so we'll start getting to some of these. Donovan is asked if there's any difference between sodas for blasting, or are all those materials the same when it comes to soda?
All right, you're going to get the technical answer. No. If you have baking soda, see, it comes down to the baking soda has a chemical structure. That chemical structure dictates a certain strength of the crystal. And we have found that, and I've been working specifically, and I'm going to brag just a little bit, since 1994 on soda blasting. And in my earlier days, when I had less gray in my hair, I did a lot of testing to determine that exact question. Was our baking soda better? We'd liked our baking soda to be better than everyone else's. And what we found was baking soda, because of its crystalline structure, if it is baking soda, it has that structure, and that structure determines its hardness. So one baking soda to another is not intrinsically different if they are actually meeting the requirements for baking soda. What we feel we bring specifically as Armex is that our manufacturing capacity. We make a lot of baking soda as a company, so and our soda blasting portion of our overall baking soda manufacture is in the minority. And essentially, you have this type of support. We have a deep understanding, and we will talk to you and ask your questions. And in terms of cost of our media, if that becomes a consideration, our medias are in line with the cost of media, might even be less expensive depending upon which media grade you're getting. And that's the other thing. We manufacture, Brian can correct me, I think we're about, 12 or 14 different formulations. They're all baking soda based, but they have different particle sizes or different flow aids for different levels of moisture protection. We have two particular medias that we have mixed in aluminum oxide in for those types of crossover applications where grease and oil needs to be removed, but they also have to have a certain amount of substrate removal. But the very, very basic technical answer is no, baking soda is baking soda if it's baking soda.
And also, just to be a little clear too, you don't want to go to the supermarket and buy a yellow box and Arm & Hammer and put in your blast cabinet. That won't probably perform the way you exactly want it to. What differs from, I could just say, baking soda you would purchase in a grocery store versus Armex or other competitive type products out there is the particle size. The particle size can determine the type of cleaning performance. Armex has 3 different particle sizes. And one of the biggest differences that, Armex baking soda provides that others do not is, Andy mentioned before about our additives. We have discovered, back in the days when making equipment, not only, we were the innovators of soda blasting back in the restoration of the Statue of Liberty, that a lot of times that the environment you work in can affect the performance of baking soda. Baking soda loves water. It loves to absorb moisture. If you're working in an unclimatized shop, a lot of humidity in the summertime, a lot of moisture around from other processes and equipment running, baking soda, straight bicarb, we'll say, has the ability to clump and lump. We have flow aids in our product which help prevent that from happening, which keeps the product consistently flowing so you won't have that clogging issues in your equipment. And also not only for when you use it, but when you store it. I think a lot of businesses out there might not necessarily have the luxury of having a climate controlled warehouse or store or tool crib, etc., where these flow aids that are in our product also keep the product stable during storage. So if you have 20 bags, a pallet of bags sitting in the corner of the shop, it's pretty safe to say that if it sat there for 1 month or 6 months, when you go to use it, it'll still be baking soda and still perform well. Andy might be able to elaborate a little bit more. There's always a lot of talk out there about particle size. What's the right particle size to use? And can you kind of talk a little bit about particle size, Andy?
I can. I can't speak to right now. I do know in the earlier days there was always the thought that bigger must always be better. And like I had said in my brief technical presentation at the beginning of our webinar, it depends. If you have a thick coating, yeah, you want a big particle to be able to penetrate. Baking soda is the same. You want to have a big particle to penetrate that soil. But if you have a thin coating, a good example is a urethane type paint. They tend to be thin. When you have a big particle, it's going to blow right through that thin coating and get to the substrate, and you're essentially going to waste energy just banging on the substrate. A smaller particle means that if you have, let's say you have 1 pound of a large size crystal and 1 pound of a medium sized crystal. Because it's a medium sized crystal, but they're both 1 pound, you're going to have more particles of medium sized crystals than large sized crystals. So you're going to have more hits shooting out the end of the nozzle for the same amount of material, same amount meaning weight of material you throw at the surface. Since you don't need all that penetrating power, you're going to actually get more hits, which can be more efficient. And I had, back in the early days when we were doing those types of basic research, we determined that there were instances where our medium-sized particle was more productive than the XL-sized particle. So yeah, that is important. And you may want to be dialing your penetration because of your substrate. As I had mentioned, baking soda lends itself to your softer substrates. It gives you more leeway. So if you have a more sensitive substrate, you may even want to use our smallest size, our composite media, so that you limit the penetration, giving you more leeway to remove whatever you're trying to move off the surface without doing damage to that surface underneath. So particle size can be important for your application. Did I get that answered to the right way, Brian?
Yes, you did. I guess the big takeaway is, the particle size is related to what you're doing, meaning that, it's the right particle for your type of job, where some jobs, larger ones work better, or medium ones or small ones. It's not a blanket statement, but the one thing that we can say, at least in this industry, Armex, we sell into multiple vertical markets. When we were involved in engine and transmission rebuilding, remanufacture, Andy explained about, 1 pound of, an extra large versus 1 pound of a medium. You have more hits with a medium. When you're working with greases and oil removal, more is better. So you want to have that more medium to, large crystal, not an extra large crystal. It'll absorb more media. More media will absorb more of that oil and grease off the surface area. But again, it comes down to what works best for you and what you're doing. So,
yeah. Especially if you're talking about combustion surfaces. Let me just finish with this last statement on this topic. Combustion surfaces, because you're going to have carbon deposits, and carbon from a cleaning standpoint is functionally inert. Solvents don't take it off. Water, aqueous doesn't take it off. There's great difficulty in getting carbon off the surface of things because of its inertness for cleaning. Abrasive cleaning does that very well. And so an XL size might be useful if you have got a mix of grease and oil and other hydrocarbons and burnt on carbon deposits, especially if they are of significant amount. So you have the next question, yes?
So yeah, we had a question about removing stuck-on gasket material on an aluminum part. What the best is for getting rid of that.
It depends upon how that gasket is affixed. If you're looking at completely dissolving that gasket material, that may require a rather aggressive chemical attack. If it's just in there with adhesive, you still may need to get that adhesive off. For abrasive cleaning, gasketing material, depending upon the characteristics of gasketing, if it's more rubbery, it's actually going to prove more difficult, even with your hard abrasives. Because remember, I was talking during the presentation that you hit the surface and it's the matter of the hardness. Now you add a new dimension, elasticity. Your rubbery surfaces are able to absorb that impact, deform, and then pop back into shape. So it actually takes more energy and more work to remove that, to scrape that off, because it's resistant to that abrasive technique. So gasketing can be very difficult. So it depends upon how that gasketing is affixed and what you're trying to do. If it's something that needs to be dissolved completely, like I said, you may be looking at some rather aggressive chemicals to do so. Especially depending upon the type of gasketing. Viton and those types of materials are much more durable. Natural rubbers, on our aqueous side, we have a water-based paint and ink remover that does degrade natural rubbers, though it might still take quite a long time depending upon how thick your gasketing is. Gasketing is tough.
All right, well, thank you. We have another question about recommendations for final cleaning after all machining processes have been performed. If you guys have a preferred method for final cleaning.
Well, preferred. If you are looking at a lot of smaller parts, parts that you want to do in batches, you probably are looking at a liquid-based cleaning methodology. If you go the aqueous route, you'll need to include a water rinse. And if your widgets are, like I had mentioned, flat and without a lot of nooks and crannies, you could do that with spray under immersion, agitated immersion, or even a spray washer. If your widgets, because you're really talking about if you're talking about metalworking coolants, unless you have a metalworking coolant that has certain properties because you're like doing something aggressive like broaching or something like that, where it's actually kind of sticky and wants to stay on the surface. A lot of your metalworking fluids are rather easy to remove, relatively speaking, to some of the other soils. So you have some leeway. If you have nooks and crannies and through channels, I tend to gravitate more to a spray under immersion cleaning technique for that reason, because my cleaner will get into those channels and nooks and crannies better. So an unsatisfying, it depends. So maybe hopefully I caught the particular types of parts that you're doing. I probably would gravitate to spray under immersion. If you have expensive parts that you have that you have other reasons to, you could be exploring soda blasting or another type of abrasive cleaning, depending upon what you're trying to move from that surface. If you're looking at trying to remove burrs, soda blasting isn't going to do that for you, because we're not going to do substrate removal. We'll knock some of the really fragile burrs off, but if you've got some significant burr, you'll need something more aggressive than that to erode off of those types of machining burrs, if that's what you're referring to in your question.
Okay. We have another question from Brian about whether you can soak small engine parts in baking soda to remove oil. Is that something that, will that remove it, or do you need to spray it?
You will probably not get the kind of results you're hoping for by just putting dry baking soda onto the surface, because there's no, you might say, motive force to get your bulk material off. It generally works better when it's sprayed. If you went the route of saying, well, maybe how about making a baking soda solution? In that instance, you still would benefit greatly from that type of a soak with having a surfactants in there with it. So I would recommend you go with an aqueous cleaner if you want to do that type of soak. And if you're doing a static soak, it's going to take longer, because as the engine's sitting there soaking, it's going to loosen, but without any type of agitation. You're relying upon diffusion chemistry principles to get the dirt away from the surface, which are much slower than if you have some sort of motion that gets you convection, your convection oven cooks faster than just a regular oven, as an example.
Okay. Then we have another question about whether soda blasting will kill grass if you're doing it outside. And I'm assuming maybe they mean without the use of a cabinet, or?
Yeah, if they're doing outside blasting, yes, it will kill grass. Because if you get a lot of baking soda, remember I said it's a soluble salt, and now we start talking about some chemistry and some physiology. Well, baking soda will if you get enough baking soda dissolved in the ground, you will interfere with the osmotic potential, meaning the desire of water to move from outside the plant root into the plant root, and you'll keep the water outside the plant. Also, too, baking soda dust on plant vegetation surfaces can interfere with the plant's ability to breathe and to photosynthesize just from physical obstruction. So you have to be very cautious around vegetation. It usually works out best to wet the ground first, so that you limit how much gets into the ground. And absolutely, if you're able to, tarp and protect that vegetation if you don't want to be killing it. So yes, it will kill vegetation for the reasons I just described. It's not an herbicide so much as it's going to interfere with water flow into and out of into the root if you get too much in the ground.
We run into a lot of this in the restoration industry: fire, mold, graffiti removal, historic preservation, where, unfortunately, if you're blasting outdoors, it's called uncontained blasting, using a blast pot. Sometimes obviously you can't prevent the migration of soda. And as Andy mentioned, we always recommend a very, heavy water rinse down of the area around the area you're going to be blasting, followed by another rinse down as well when you complete it, and obviously try to put as much plastic or tarps down over vegetation if possible. But there is ways you can put precautions in place, though.
Yeah, very good. Just to give the audience a heads up, we are at the top of the hour here. However, we do have a few more questions out there, so we're gonna keep going a couple minutes longer. If we don't get to all the questions, we will make sure to respond to those in the email. and get you guys the answers to those questions. But hang tight, we're going to keep going for a few more minutes. We do have a question here about the best method for getting honing grit out of cylinder bore. He's been told that solvents will not remove the grit, that it would be better to use warm soapy water. Any comments on that?
So it depends upon what the grit is. If it is an insoluble grit, and I don't know, and I'm sure there are many different types of honing grits, so I'm not going to make any assumptions, but I am going to, but except for this one, that I'm going to assume it's water, well, potentially water insoluble. Yeah, if it's insoluble, it may be, it's obviously insoluble in an organic solvent, not necessarily uncommon. If the honing grit is actually some sort of soluble, and I'm going to use the chemistry term salt, not sodium chloride, but a soluble salt chemistry term, then yeah, the warm soapy water could definitely work to remove that if that's its nature. If it isn't, if you have some way to either you soak them with the cone side down so that you get some effect from gravity, and then also too, I would probably lean just from a knee-jerk response to using spray under immersion. But you could also think about, if it's a longer type of cone, fixing the narrow end to some sort of pump apparatus to flush it out with an aqueous solution to help move that out. If the parts are worth it, and you're not talking about a large number of parts that you need to be cleaning in this methodology. If that's the case, we'll put the cones in face down so that gravity's pulling down out through the widest area, and yeah, soak them. If he wants, he can, that particular questioner can send that to me via our inputs, and I can answer that more specifically if he's able to divulge what the honing grits material actually is.
Very good, thank you. We got a question from Cody. You mentioned spray under immersion just now. He's asking about nozzle type for that, and whether it should be kind of a fan style or more stream-like.
For spray under immersion, it tends to be just an aperture because of the way it functions. A spray under immersion does not, quote unquote, spray directly onto the parts. Its purpose is to create a roiling, convective, chaotic flow of cleaner in the bath itself. And then that chaotic flow is what impinges and cleans the parts themselves. When you talk about a spray washer, they tend to be a pretty standard little spray nozzle. We don't make the machines, so the manufacturers make them that way. They generally just use standard types of little fan spray nozzles on their spray arrays that are spray bars that are inside the spray washers.
Very good. Guys, we'll kind of wrap up with this question here. I know there's a lot of questions you guys get about wet versus dry blasting. You guys want to kind of talk about some of those common things you hear and address what some of those differences are?
So, wet versus dry. If you're going to be in a blast cabinet and contained, most likely it'll be easier to do it dry. There are not, to my mind, and Brian can correct me if he has some information that I don't have, there currently aren't very many blast cabinet wet / slurry type of containment cabinets for cabinet type of work that way for soda blasting. I do know that there have been slurry cabinets for some hard grit. Hard grit tends to be easier because the hard grit doesn't break down as rapidly as soda in that type of environment. For exterior blasting, wet blasting does have its place. It's a lot less dusty because it knocks it down. And we have seen that for certain types of applications, the parts look cleaner and brighter after wet blasting. We have always hypothesized that has to do with the water molecules being accelerated in the airstream, getting down into the molecular valleys that are on all parts. We don't see them even on a smooth part, but there are molecular valleys, and the water molecules being so small, with force behind them, get down in there and help to get some of the dirt that we might not be able to get on a molecular level off of a surface when we're doing your abrasive cleaning, and you have a rather macroscopic particle compared to the size of a molecule. So that's what we've seen with wet and dry blasting. Again, what is the needs of your application, and what are you looking to do? A lot of your wet blasting is in an exterior environment, and they're utilizing the water for containment. That tends to be the primary method, primary reason for that method.
Yeah, dust reduction. There are a couple manufacturers out there that do make vapor blast cabinets. We haven't really seen a huge following yet in the rebuilding, remanufacturing areas. We have seen them in more use in different type of MRO type usage or other type of applications. I think Andy kind of hit it spot on. You know, I don't think you could say that, you know, one might lean better to the other. It just comes down to, I guess, what's best for your process, you know, what's going to perform best for what you're trying to clean. Dry blasting is definitely the more dominant cabinet blasting in this industry. And it's probably that way just because, you know, the technology of vapor really hasn't taken on too much yet in the contained cabinet side. You know, there's obviously pros and cons of both. You know, dry blasting, you're going to have that dust issue in the cabinets. You need good extraction. Wet blasting or vapor blasting, that dust issue will be greatly reduced, but now you have to deal with water. What does that mean? You know, when you're dealing in a dry cabinet, you have an extraction unit that extracts all the dust out, meaning both your blast media and your contaminant that you're cleaning. It'll be dropped into a drum per se. Now you're dealing with water, and you have a constant flow of water, and now you need to kind of capture and contain all this water. In some large facilities, more in the dry way than the wet way, what they tend to do is they'll take their waste generated from dry blasting, meaning the baking soda, whatever contaminant, they're able to dissolve all the hard abrasive, i.e. soda, and water. They skim off all the hard contaminants, oil contaminants, and then they'll take that pH water and put into water treatment facilities in their plants. So there's different ways of handling it. I'm not really familiar of too many larger shops or reman facilities doing vapor yet, but I know that there's been a couple very large, now we're talking rebuilders that are building diesel engines the size of small cars. They have embraced vapor blasting mainly for the first processes. They'll have these massive engines and they will vapor blast the complete assembled engine before they start tearing it down. They get all that grease and oil and all those contaminants off. And then after that part, they break the engines down, and then they'll obviously clean it, and they'll rebuild, reman each individual part from there.
Very good. Well, guys, like I mentioned, we're kind of running out of time here, and for any of the questions that we didn't get to, we will make sure to email responses to those. And again, I want to give a big thanks to both Brian and Andy for being here with us today and sharing their expertise. And again, for the audience out there, we will make sure to get to those questions that we might not have answered. And lastly, today's event was recorded. So if you're looking for to replay this or share this video with other folks, there will be a recording link that will be emailed to you, and we will also post it on the Engine Builder channels and the RMX channels as well at a later point. So again, I hope you guys found this informative and beneficial. Thanks for being here. Andy and Brian, thank you guys again, and hope you guys have a great day.
Thank you.
All right.